Okay, so we're given an equation of a line in this particular format. Probably not the format I want, so what I'm going to do is make this equal to lambda, then I can rearrange it. So x is 4 lambda plus 2. So line 1 I can write as x equals x, y, z equals 4 lambda plus 2. Y is minus 2 lambda plus 4. And z is lambda take 6. And perhaps more usefully, if I put the 2, 4, minus 6, take the lambda out, I get 4, minus 2, 1. Okay, so this gives me a point on the line and the direction of the line. Now we're also told the equation of a plane, which is x minus 2y plus z. So what that means is the normal to pi is the vector 1, minus 2, 1. Okay, that's the direction of the normal. Okay, so if we attempt to draw some sort of diagram, never easy in because it's a 3D drawing obviously, but anyway, let's have a go. So we've got some sort of plane which we're going to call pi. We've got a line going through the plane and we don't know the orientation, doesn't really matter. Let's make it look like it's coming through the plane. There we go. So that's L1. And then we've got the normal to the plane, which we know that's the normal to the plane, and that's 1, minus 2, 1. I'll call that N. Okay, now it asks us to find the equation of L2, which is a reflection. It's going to be quite hard to draw this, but a different colour. Hopefully you get the idea. So it's going down through the and then down here somewhere. Okay, so reflection in the plane, and the way we're going to do that is we're going to what we're going to do. We're going to find this point here where the line intersects the plane. We're then going to pick a point on L1, and because we know the direction of the normal is not quite right here, we know this is some multiple of 1, minus 2, 1, and then we're going to double it or do it again, so we get a point on this line, then we've got 2 points on the red line, and we can find the equation. Okay, that's our general strategy. Let's first of all find this point here where it intersects the plane. Now we know that we've got the equation of the plane, which is x take 2y plus z equals 6. I know the equation of the line. I've got the x, y and z values at the top here. Got x, got y, got z. If I substitute those in, I get x, which is 4 lambda plus 2. Take away 2y, which is plus 4 lambda minus 8. Plus z plus lambda minus 6 has to equal 6. I then get 9 lambda equals 18. That implies lambda equals 2. So let's call this point A. The position point of A, or the position vector of A, is going to be, just put it back in again to find the x. So x is 4 lambda plus 2. 4 2's plus 2 is 10. y is minus 2 lambda plus 4, which is 0, and z is minus 4. Okay, so I've got 1 point on the red line, and sort of on the black line as it happens. I'm going to pick another point on L1, and probably the most convenient, I'm just going to go for 2, 4, minus 6. Alright, because I know 2, 4, minus 6 is on the line, and that's the direction, so that point's on the line. Now I'm going to go, I'll call this B. I'm not sure I need B or not, but call this one C. Okay, so moving this up, I know that if I start from 2, 4, minus 6, add mu lots of this, I'll end up on the plane. Alright, so B is 2 plus mu, 4 take away 2 mu, and minus 6 plus mu. Okay, that's the position vector, position point of B. I know it lies on the plane, so if I substitute that in, I should be able to find mu. So again, I know that x minus 2y plus z equals 6. So x, so that implies 2 plus mu, take away 8 plus 4 mu. Minus 6 plus mu equals 6. That gives me 6 mu is 18, so mu equals 3. Okay, so mu is equal to 3. So now I could work out point B. I don't really need point B, right? I actually need point C. So I'm going to find point C is 2 plus double, so 2 mu, and the 4 take away 4 mu, and minus 6 plus 2 mu. Okay, because I'm going mu lots to get to here, so 2 mu lots to get to here, so I'm going to double it. And I know what mu is now, so I can just put it in. 2 plus 2 mu is 8. That becomes minus 8, and z value is 0. So finally I can find the equation of line L2, because I've got 2 points. I've got point C, and I've also got point A. So line 2 is x, y, z. I want a point on the line. I'm going to pick A or C, doesn't make any difference. I'll go for A, is 10, 0, minus 4, plus some multiple of the vector joining them. So how do I get from A to C? Go from C to A. I'll go from A to C. Doesn't matter. So from A to C, I go from 10 to 8, so it's minus 2. From 0 to minus 8 is minus 8. And from minus 4 to 0 is 4. I mean, there's obviously lots of ways this could be written. Perhaps you wouldn't have a factor 2 in here, but it's perfectly correct. Or we could write the same line, the same as this. Minus 1, minus 4, and 2. But as I said, this one here is perfectly acceptable, but it's not unique. Remember, because I could have picked this first point as being C rather than A. This could be the negative of it because it's going the other direction, and so on. Okay. There is a much quicker way of doing 7a. It's less versatile, but it will certainly answer this question a lot quicker. So if we go back to question 7a, if we look at the formula at the bottom on the right here, the perpendicular distance formula, if we put the plane in this form here, so our plane is going to be 3x take away 4y plus 2z take away 5 equals 0. That's A, B, C, and D. And we know the point, and we're interested in, is 6, 2, 12. So the perpendicular distance, we're just going to plug the numbers in. So it's going to be 3 times 6. So perpendicular distance is 3 times 6. Take away 2 times 4 plus 2 times 12 plus D, which is minus 5, all over square root of 3 squared plus 4 squared plus 2 squared. Notice the modular signs at the top, which means it's a distance, so we take the positive values. So I'll put those back in, doesn't matter in this case. At the top we get 29, at the bottom we get root 29. So 29 over root 29 is just root 29.